Welcome, my dear students and the real GATE aspirants, to this simplified video presentation on preparation strategy for GATE Electrical Engineering EE. As a team, we are subject experts from ACE Engineering Academy. Together, we would like to talk deep into the strategy for cracking GATE in very first attempt of electrical engineering branch. Now let us first define what is quality and what you need, that is perfection, to achieve such quality, as GATE is a very good quality fundamental knowledge exam on technology in India. Now quality is never an accident, it is always the result of high intention, sincere effort, intelligent direction and skillful execution, as it represents the wise choice of many alternatives. So GATE is a very good quality fundamental technical exam in India, and to achieve this we require perfection. What it means? Perfection is the action or process of improving something until it is faultless. So my simple idea to start this presentation is to achieve such quality exam and be successful in it. Let us also be perfect. Now the agenda for this slideshow is, we have a strategy especially for electrical engineering branch. We will do result and mark analysis. We have in detail subject analysis by our team of subject experts, and then we will also argue and communicate about how to answer certain model questions and then recommended material and books. And then I will brief out on general suggestions for serious GATE aspirants of electrical engineering branch. Now strategy. Now these are competitive exams. So let us understand what are the steps required to really attempt and crack these competitive exams. In simple, step 1. Understand the difference between university exam and competitive exam pattern. Now I want to just show a slide. Now university exam paper is about making the student learn and study to qualify. Then we have the grading system, CGPA system, percentage we say, first class, distinction. But competitive exam on the other hand is an elimination process. On the other hand, it is to restrict the student because opportunities at that high quality are very limited. So these competitive exams are different from university exams, where university exams are about qualifying the student, but competitive exams are about the restricting the students. Then step 2, understand the pattern of competitive exams. The best resource is refer previous exam papers, and especially GATE, since 30 years we know its quality. So please refer and understand the latest pattern. Then step 3, plan further yourself based on your strength and important subjects. Step 4, try to answer at least one question paper within the given time, and you will have the ability to generalize and understand your capability. Then based on that, take a feedback and do the strategic preparation accordingly in the available time. Now what are the qualities that a GATE aspirant should have? Lot of dedication, of course, and patience to read and write, adaptability to the question, the type and the nature, accountability for the money and time, and of course intelligent, and most importantly not just hard work, it is smart work. Now this GATE exam, I want to just brief out about the standard and the quality of this exam. This examination primarily tests the comprehensive understanding in engineering, technology, architecture and sciences, conducted by IISc and all IITs every year in the month of January, February. The GATE score or rank is used for admission into MTech, ME and also PhD in IITs and IIScs, and other universities in India with financial assistance provided by Ministry of Human Resource and Development. The GATE score, as you know, is now also used for PSUs for recruitment of candidates for prestigious jobs, and all PSUs Navaratna we call. So this GATE exam, which is also used for public and private sector undertaking, due to this reason it has got great competition. Now, as per the latest change in pattern for GATE, now we have certain sections like general aptitude and English. That is 1 mark, we have 5 questions, 2 mark questions 5, so total 10 questions for 15 marks. And the next thing is electrical engineering and maths. There are total 1 mark 25 questions and 2 mark 30 questions. So in total 55 questions for 85 marks. Negative marking for multiple choice questions do exist. So it is 1/3 of a mark for 1 mark questions and 2/3 of a mark for 2 marks questions. However, there is no negative marking for numerical type questions. So in general, if you talk about the latest pattern of GATE, total there are 1 mark 30 questions and 2 mark 35 questions. So in total 65 questions which carry 100 marks, and the most important thing is the time duration to achieve this is 3 hours, that is 180 minutes. So you should be well aware about the latest pattern in GATE. These are some of my suggestions. Like, I would like to classify this entire GATE question paper into 3 categories based on the quality of questions and the weightage of the marks to score. Like category 1, let me correct it, aptitude and engineering maths, that is 25% to 30% of total marks. Then these technical subjects I would divide into 2 further categories, like overall category 2, fundamental common subjects, that is 40 to 45% of total marks, and then the core subjects in respected science like electrical engineering, that carries again 25 to 30 marks of total marks. Let us go in detail. Now when it comes to general aptitude, which is common to all papers, which comprises of verbal ability, that is English grammar, sentence completion, verbal analogies, word groups, instructions, critical reasoning and verbal deduction. It also has numerical ability questions, numerical computation, numerical estimation, numerical reasoning and data interpretation, and also engineering maths. Now engineering maths is all about applications. So according to me, this category 1, which is on aptitude and engineering maths, can give you around 25 to 30 marks, maximum 30 marks. So most of the students are very comfortable, so I suggest you to attack this section first while writing exam, which is approximately 30 marks and in 30 minutes. So if you can attack this English and mathematics in the first half an hour, you have every chance to automatically qualify, and you beat almost 80 to 80% of the competition in the first half an hour. Then I categorize the technical subjects into 2 types, common, fundamental subject. But these common subjects generally appear in our first 2 years of our BTech. So they are very fundamental, highly numerical subjects like electrical circuits and fields, control systems, signals and systems, analog electronics, digital electronics and microprocessors, and electrical and electronic measurements. So the nature of these subjects is highly numerical, full of problems, so a lot of practice is required to attempt them, but they are easy and fast and they constitute bulk marks to score. So my suggestion is, after this aptitude and mathematics, please attack these common subjects, and while preparation, first complete and clear these subjects before you go to deep core subjects, because having thorough knowledge on these fundamental common subjects will always ensure you to be more easy way to learn the big things in your life. So concentrate more on these subjects, because they not only give you more marks but in less time. Then I categorize the core subjects, which is the second part of technical subjects, the subjects like electrical machines, power systems and power electronics. Now you know these subjects take generally long time to prepare, and also in exam one require a good theoretical knowledge, principles, concepts, lot of mathematical derivations and applications. But no doubt they are the most important future MTech subjects which have to be at any cost understood by the student, and also these subjects are the most preferred subject in interviews where you apply for technical jobs. Then you know, like GATE is highly numerical and application, and it is now aptitude in nature. So there is nothing much to write in the exam except aptitude skill and logical thinking you develop. And you know 80 to 85% of weightage is for numerical questions, only 20 to 15% of questions are for theoretical, and that too very rare in electrical engineering branch. Then I categorize these technical subject questions into 4 types. Type 1 is recall type. These questions are to be answered from memory of the subject or one-line computation and based on definitions. Now second type questions we do encounter in our GATE exam technical subjects are comprehension type. These questions test the candidate's understanding of basics of the field. Then the third category are application based questions, which are very good. He has to apply his fundamental knowledge either through computation or by logical reasoning. And the fourth important category of technical subject questions are analysis and synthesis questions. These can be linked answers questions and common data questions. Now we have total 65 questions in 180 minutes and 100 marks. So you see average 3 minutes, but I think you not even get 3 minutes, as some of the aptitude questions are very easy, but some of the linked questions and 2 marks questions you may take more time. You have to instantly answer in less than 1 minute, and then this extra time you have to allocate to the real quality core technical questions. So time is more important to manage. Then you know, like these days it is online, but still clicking data, everything, it will take some time and difficult to answer all the questions within the time, you know that. So target about 90%. There are certain questions which are maybe due to the topics you did not cover, or you are unable to strike the idea and the concept. So some 10% I think you may take a chance, but target perfectly 90%, which is also good enough to get top rank, because I will discuss about the score and the ranking, which I will tell you in general. So it requires thorough knowledge and practice. Now my suggestion to achieve this good objective standard exam, objective based exam, is to gather standard textbooks and relevant material, make a wide extensive study of theory, read and note down important points on every topic exactly as per GATE syllabus. My suggestion is write short notes where memory plays an important role to remember certain things. Then understand the fundamental concept clearly from root level. For that I suggest you read a simple good textbook once. Then concentrate more on mathematical modeling and equations. So finally GATE is a mathematical paper, so concentrate on mathematical modeling and equations. Then after that, practice previous objective questions of GATE and other PSU exams, including from common branches, the subjects from common branches like networks. If you talk about networks or circuit theory, it is there for EEE, EC and instrumentation, so include that. Then avoid reading irrelevant theory and huge derivations, but remember the mathematical conclusions in them. Then concentrate for more on numerical problems. Then focus on application based problems. Then while attempting, be careful about negative marking. Then sometimes elimination techniques for some questions, like see the all options. If you are good in concept and theory, sometimes reading all the options will give you clarity, and eliminate such options which are not correct will give automatically the correct answer if you are not sure. Then time monitoring periodically is very essential. You allocate, like as I told Nasser, first half an hour you allocate for aptitude and maths, then you come for technical subjects. So you should monitor and allocate time periodically and check this. Now I want to give some basic idea about the history of GATE exam. Like in electrical engineering, if you look at into last 4 years, 2018, 17, 16 and 15, now these are the cutoff marks of the students. Like in general category in 2018, this year, 29.1, this is relatively high, and OBC 26.1, and SC, ST and physically handicapped, it is 19.4. And if you go to 2017, 2016 and 15, you can observe the typical cutoff marks for general category, OBC and SC, ST and physically handicapped students. So generally I would take an average of last 20 years, around 25 marks in general are the cutoff for general category, and 22 marks for OBC, and around 16 to 18 marks is for SC, ST and physically handicapped. Then if you also look at all India first rank marks in EEE electrical engineering, these are such students who achieved that great milestone, and you see at the data, like in 2018 a student who got first rank did achieve 94 marks, that was fantastic. But otherwise you see the average, and 2017, 16 and 15 it is 81.25, 88.39 and 75.96. Of course that depends upon the standard of the paper that is set by these IITs, but in general anything around 85 would be a very good scorecard where you will definitely achieve single digit rank. Now if you look at the analysis about how many students are appearing, how many percentage are qualifying, see 2018 approximately we know that 1,21,380 students appeared for GATE exam. In that 19,421 qualified, approximately 16. But however in 2017, 16 and 2015 if you see, these are the number of students who attempted and appeared, and number of students who qualified and their percentage. So if you carefully look at that, it is ranging from 12 to 16%. Okay. Then let us talk more about electrical engineering branch. Now I made a good slide taking the averages, and I divided all the subjects and I categorized into 3 types as I told. Technical subjects which are fundamental common, and then we talk about the technical core subjects, and then engineering, maths and aptitude. So for the last 4 years I could divide the marks for each subject and their importance. So you can observe the average marks scored in each subject in the red color of the slide. So there are certain subjects which are highly scoring, easy to prepare and fundamental, but there are subjects which require more mathematical detailed analysis, but they are very important. And general aptitude is always for 15 marks. Engineering maths again it ranges from 9 to 14, okay, average is 12. So you should know like which subjects you are weak, which subjects you are strong, where to concentrate more. Based on that you need to have a clear strategy and improve in every subject. Then regarding material, read relevant prescribed textbooks. Now sir, reading textbook habit is very important. In most of your BTech curriculum 4 years, yes, I would expect that you did it. Just take one simple textbook which are Indian authors or sometimes foreign authors, but just read and do solved examples. Then we also suggest our ACE Academy classroom notes from subject experts. ACE Academy classroom published material like volume 1, volume 2, which we do it in the class for the students who join our institute, and also all previous years GATE solved question paper booklet, which includes for the last 30 years or more, and then we have divided it chapter wise and subject wise, which is from our publications, that is Age Engineering publications. Then for common subjects such as controls, networks, signals, analog, digital, measurements, you also practice the GATE question papers from these branches also. And we also suggest to practice more bits from bits and bytes edition of AC engineering publications. And then the most important step is to write lot of exams, practice test. Then based on this test, self-evaluation and feedback can be taken. So this is regarding material, what I suggest. Then, yeah, this is the slide showing our ACE engineering publication. We do collect all the previous papers and detailed solution, and each solution in detailed analysis in multiple methods we do solve and share the knowledge with the students. Then let us talk more subject wise. Now here I will be discussing specific to some subjects, and as our team also will talk about the remaining subjects, and I will be talking about the fundamental subjects, like the first subject, like electrical circuits. We call it electric circuits as per GATE syllabus. Now this is the detailed syllabus of this subject: network graph, Kirchhoff current law, KVL, nodal and mesh analysis, transient response of DC and AC networks, theorems, two-port networks, three-phase and power factor in AC circuits. As you know, this subject is 1 year or 2 semester course. So this is definitely a good subject to start with, and a fundamental rank 1 subject. I say rank 1 because the basics in this subject are so essential for electrical engineers. So this subject is highly numerical. Now I did an analysis on this subject, and I would share the marks division based on the chapters. Now you can see in the slide that these are the typical marks for the last 4 years. But generally now you can be easy to understand that which areas more questions come, which chapters are so important. Like you see network elements, very important, fundamentals, they have more scope to be asked. It discusses about RLC components, their interconnections, waveform analysis, reduction techniques, etc. Graph theory or topology, as you know, odd year, every odd year, here and there it is coming, but it is a very good chapter. Theorems are no doubt guarantee questions. Then transient response, dynamic response of a circuit, no doubt that a quality question always every time appears from this chapter. Then the bulk of the marks come from AC steady state analysis, and that chapter also includes resonance, magnetic circuits, okay, AC steady state, everything. Then three-phase circuits, no doubt it is very important for electrical engineers, and then two-port networks. I would like to now take up some questions on this subject based on the 4 categories as I told. As I already told, these technical subject questions are into 4 categories. Now first let us take a recall type question. As I told, recall type questions is purely based on the definition and memory and the fundamental knowledge related to a particular topic. Like a sample question I am going to discuss with you. Now in this recall type question, he is asking, a practical current source is usually represented by what? Now the student should have knowledge on what is practical current source. So my explanation is very simple, that practical current source will have a current source in parallel with large resistance, and that resistance will model the leakage current and losses. But if ideal, as we discussed, yes, resistance should be infinity. Now I will take another sample question on comprehensive type or comprehension. Now this question is about capacitors, a very interesting question from GATE 2013. There are 3 capacitors whose values of 10, 5 and 2 microfarad are connected as a network shown with the breakdown voltages. Now these breakdown voltages are the rated voltages, that if these individual capacitors exceed this rating, they will undergo breakdown, that is puncture, we say dielectric breakdown or puncture, flashover, which is very dangerous. Then in this interconnection shown, what is the maximum safe voltage that can be applied to the entire combination, that is entire network, and also correspondingly total charge stored in this system of capacitors. Now first of all, it is a very interesting question which tests the knowledge of a student who know about principle of operation of capacitor, voltage division in a capacitor, charge concept in a capacitor, that is the Ohm's law. So this particular question is definitely testing all the comprehensive knowledge on these capacitors. And moreover, these capacitors are of dissimilar rating. generally in our design we never undergo or consider dissimilar ratings, but is a very interesting question is testing fundamentals by considering dissimilar rated capacitors. Now because they are dissimilar rated, now voltage division is very interesting. Let us look at the solution. Now let us assume that a maximum voltage of Vmax P appeared across this system, that is network, and now you see in this connection, because they are dissimilar rating, I am comparing with each capacitor separately. Now with respect to 10 microfarad capacitor, directly Vmax can be 10 volts, and when it comes to 5 microfarad capacitor, now voltage division in capacitors is inversely proportional to their capacitance, and it can take maximum of 17.5 volts. And with respect to 2 microfarad capacitor, again divide the voltage, Vmax will be 2.8 volts. So in this interconnection, based on their rating, 10 microfarad capacitor can take 10 volts, 5 microfarad capacitor can take only 17.5 volts, and 2 microfarad capacitor can take only 2.8 volts. Now because they are dissimilar rating, with respect to them, these are the maximum allowed voltages. But altogether, now that is very interesting, now altogether he is asking what is the maximum safe voltage. Now the maximum safe voltage for the entire connection is the minimum value, because we know in an interconnected system like a chain, you take an example of a chain, in an interconnected system like a chain, the strength of the chain is the strength of the weakest link in it. So the weak capacitor will decide the overall rating of the system. So my final answer is only 2.8 volts. Now when you give this maximum safe value of voltage, that is 2.8, then the maximum storage charge from Ohm's law, Q equal to CV, we do get 32 microcoulomb. Now let me take another category question in my subject, that is networks, that is sample question 3. It is application type. Now this is a very good question on application. Now this question tests the thorough knowledge of a student on dynamic behavior of circuit, which is transient operation, and also a diode, which is a unilateral device, to a pure LC circuit. And this application comes from power electronics, which is an important circuit we do study on commutation process of our power electronic devices, especially thyristor. So this concept do appear there. So this is a very good question linking circuit theory transient to power electronic commutation circuit. Of course these days commutation techniques have improved a lot, but this is one of the classical way to commutate a conducting thyristor in power electronics. Now see this question, he said that the switch is closed at t equal to 0 with no initial condition on inductor as well as capacitor, but is asking what is the final voltage across capacitor when a DC 100 volts is applied across it. Chalo, in that regard, now this question we can also solve in time domain as well as in Laplace domain. Now the student should be matured enough. If you do time domain by taking initial condition, writing equation, differential equation, solving, taking integral constant, that is a lengthy process. Now the student should have, this is an application, and what is the easy way to do? Yes, my suggestion is the easy way to do is in frequency domain, that is Laplace transform. So now I will consider this circuit and I am just suggesting this solution, see how simple it becomes in Laplace, but in time domain it will take a lot of time. Now let us first write the S domain equivalent of the circuit without any initial condition, and I am writing a KVL. From that I got the expression for voltage across capacitor in frequency domain. Then I do inverse Laplace transform. After taking partial fraction, I got the expression in time domain. But we know because this circuit has a diode, we know diode conducts only for positive cycle, that is as long as the current is going in positive direction from anode to cathode. So the circuit conduction time omega c, that is omega, which is Tc pi by omega. So if you consider this as a tank circuit neglecting diode, you know in tank circuit the frequency of oscillations will be 1 by root LC. So now if you apply this circuit conduction time where the diode conducts only for half cycle, then the final voltage across capacitor is 200 volts. So the very interesting question, that at the source we are giving only 100 volts DC and suddenly switching it, but the final steady state voltage what capacitor will achieve is 200 volts. That is very interesting. You know, the stored energy in the inductor also will be now stored in the capacitor in electrostatic form. So the overall voltage is 200 volts, which is very easy in frequency domain. Now I will take another sample question. This is another type called analysis type. Now this question is analysis type, and I took this from AC steady state phasor diagrams, a very interesting question. That there are 3 voltmeter readings in the circuit. One is supply voltage, one is a voltage across resistor, one is the load voltage, and now he is asking us to determine the load power factor. Now this circuit require a lot of analysis through phasors. So this is another category of question called analysis type. Now in this type question, the student should have thorough mathematical knowledge of how to understand, because the elemental values are not given, but phasor diagram can help us. So that phasor analysis is required. So let us go to the solution. Now I am first drawing the phasor diagram. Because it is a series circuit, I took current as reference and then plotted the voltage across resistor and the voltage across entire load, as well as the total supply voltage, which is the KVL phasor sum of V2 and V3. Then we know there are 2 individual components, V2 and V3 we know, and the total resultant also we know. But he is asking load power factor. Load power factor is the angle between load voltage and load current, that is cosine of angle between load voltage and load current, that is nothing but V3 and I. But because V2 and I are in phase, it is also nothing but the angle between V2 and V3. So we know from phasor diagram that V2 we know, V3 we know, and the resultant also we know. So I use the simple fundamental formula that comes in our physics, like resultant of 2 vectors. Like if you observe that resultant of 2 vectors, that cos of phase angle is our load power factor angle. So this is linking to such basic fundamentals we learn in our intermediate to an engineering application, which is a very interesting question on analysis. Then my suggestion for standard reference books for electrical circuits. There are very good books in the world written by great teachers and authors. Rather than asking you to read all books, which is not possible, one of these good books you can refer. But apart from that, as I told, that we do provide a very unique, simplified material and notes from our institution, but still these are world class books, and my choice specifically is for Fundamentals of Electrical Circuits by Alexander and Sadiku. Like I will take another subject on analog electronics. I want to just share my knowledge out of how to attempt these questions on this subject. Now again, the syllabus of this subject, that is characteristics of diodes, BJT, MOSFET, diode circuits, clipping, clamping applications, rectifiers, amplifiers, biasing, equivalent circuit and frequency response, oscillators and feedback amplifiers, which is very important, op amps, no doubt, it is one of the major area of analog electronics, and characteristics and applications, and then filters, voltage control oscillators and timers. So this is the syllabus mentioned in GATE. Then again, I did my analysis on the marks division on these individual chapters. Now if you look at that, now these are the areas where I divided the entire syllabus into these subsections and chapters, and these are the typical division of marks. Then you can understand that there are some areas where questions come frequently with more marks, and some areas here and there they do appear. So the student should have thorough knowledge in understanding this subject and understand the areas where you have to strengthen more, like especially like op amps, BJT and FET biasing. Okay, these are the major areas, and also diode circuits. Now here I am again going to discuss some sample question. Like look at this question. Now this question I would say it is one of the fundamental question, like is asking in this feedback network shown, if the feedback factor is K, then what is the effect? Now it is of course from GATE 2013, and these are the options. Now if you look at this arrangement of this interconnected network, now it is a feedback network. Now that block above would represent the analog circuit, but the block below is the feedback. But you see clearly at the output side is taking voltage, that means shunt feedback. Now if you connect any element in shunt, the resultant impedance go down, so output impedance decreases, and is connecting this feedback loop path to the input side in series, that is current. So you connect any element, impedance increases. So my answer is definitely input impedance increases but output impedance decreases. So that is how, this is a question where student should answer based on the fundamental knowledge. I would also like to take another question, sample question, which is about op amp. No doubt this is a major area, an important chapter in analog. Now this is talking about a non-inverting op amp amplifier is shown in the figure, then the output voltage is dash. Now this is analysis type question. I would now put this question into analysis type. This requires some mathematical solving. As you know, what are the characteristics of ideal op amp and the concept of virtual ground. Now if I apply Kirchhoff current law at node B, okay, which is of course, and I also applied KCL, that is at node A. Now after applying this KCL at these nodes and substitution, we got the total output voltage as 3/2 sin 100t. So this is a very good analysis question where you have to apply the fundamental knowledge, understand the concept of ideal op amp and virtual ground, and then solve this equation to get the final answer. Then my suggestion for this subject, there are some great books, and of course my first choice goes to Microelectronic Circuits by Smith and Sidra. Then specifically for op amps, this is a very good Indian author book, that is Ramakant and Gaikwad, and there are much specialized books which also talk certain design levels in industry, that is Boylsted. So I suggest to take any one of these as reference and do the solved examples in it. Reading entire book is unnecessary, but do the solved examples in it, and based on the weightage and marks and the chapter allocated marks which I did. So another subject, as I told, that digital electronics and microprocessors. Again, this is the detailed syllabus mentioned in GATE exam. Combinational and sequential circuits, multiplexer, demultiplexer, schematic trigger, sample and hold circuits, analog digital conversion and digital to analog conversion, 8085 microprocessor. Yes, that is an important chapter. Its architecture, programming and interface. Now again, I did divide these chapters, and I could also do the average allocation of marks in the recent 4 years. Of course, this 4 years does not give the entire detailed analysis of marks division, but definitely microprocessor, as I know, its average is 2, though in the last 4 years I could not see any question from electrical engineering, but before that its average is 2, so don't underestimate that chapter. But generally you see sequential circuits and combinational circuits are the most important area, then logic gates and Boolean algebra are the easy things to attempt, and analog digital converters as an application. So these are the areas that you should concentrate, and especially microprocessors. Then here I am discussing a sample question. Now this is an application of digital electronics. It looks a simple analog circuits, but please understand, now this is a transistor operating as a switch, so it is a digital question here. Now see this, the logical gate implementation using this circuit shown below, where input voltages V1, V2, where 0 volts stands as digital 0 and 5 volts stands as digital 1, and the output is dash. Now he is asking, this acts as what gate? Now you know this comes under combinational logic, and we are talking a practical circuit where transistor is acting like a switch into gate, logical gate. Now simple, you know how transistor work, you bias it and give input at the base, output is collector side, it will conduct. Now if I take V1, V2 as the two basic inputs for these voltage levels 0 volts and 5 volts as 0 and 1, and I am just writing the truth table. You look at this, if both V1 and V2 are 0, both transistors are off, full output will be conducting, so output is 1. But if either of transistors is on, then definitely that path is grounded, output is 0. And of course if both are on also, the output is 0. So this clearly represents NOR gate. So this is a very good question which is testing the basic fundamental knowledge of student into digital application as transistors are operating as a switch from the truth table. And this basic subject like digital electronics, I would suggest these books like Morris Meno. This is a fundamental book where every BTech student is aware of. There are much better books like Modern Digital Electronics by R. Jain, and don't neglect this. I told us microprocessor is a very important chapter, though in the last 4 years we could not get, but in general it is definitely 2 marks, and you know its programming is very important in any industry. So microprocessor architecture, programming and applications with 8085, that is Ramesh Goenkar is my referred book which I suggest to you. Then I would also like to discuss brief about this subject like signals and systems. Now in 2011 this has been included for electrical engineering. Generally in our BTech curriculum this subject we do not study in most of the universities, but at GATE level this is a very important subject and it is a common subject to electrical, ECE and instrumentation. Because when you now join industry, though you are from power engineering side or signal side, lot of interfacing and thorough knowledge is required. So signals and systems is another important added subject in GATE where students should have thorough knowledge, and it is a highly mathematical subject, and this is a complete syllabus representation of continuous and discrete time signals, shifting, scaling, linear time invariant, causal systems, Fourier series, sampling theorem, application of Fourier transform, Laplace transform and Z transforms. As you know, these are very important for electrical engineering applications. So though we don't study this in our regular BTech curriculum, but as applications and when you join for research and industry, this is a very important subject. So don't neglect it. Generally the electrical students have a mindset to neglect these electronic side subject, signal side subject, but very important, and let me tell you they are more easy and we can score in less time. Now again I divide this entire subject into these chapters and the recent marks division for the last 4 years. So from that you can easily analyze that Fourier transform, Z transform, see guarantee question, and Laplace we do also get in other subjects, so somewhat less weightage, but still LTI systems, their definitions, sampling techniques, these are all very important. I just gave the average of 4 years, and now I am discussing a simple question there. Now this is a very important question linking the concept of resonance with signals and systems. Now see how good this question is. A symmetrical square wave of 50% duty cycle has an amplitude of plus and minus 15 volts at a time period of 0.4 pi milliseconds. Square wave is applied across series RLC circuit with these values of RLC. The amplitude of the component which is at 5000 radians per second across the capacitor is asking. So the amplitude of 5000 radians per second component of capacitor voltage in volts. So very interesting. Generally in network theory we study AC steady state, that is for sinusoidal excitation. But the given input signal is a periodic signal, but it is a square wave. Now the student should have that knowledge. A square wave talking about voltage across capacitor, and that too a component he is calculating at 5000 radians per second, that means it comes from Fourier series. So that is where signal application is mentioned here. Now just let us discuss the solution here. Now for the supply waveform, if you do Fourier series, that is the expansion we get, that is sigma 4 VDC by n pi sin n omega t. Of course omega he is asking 5000 t, and as it is symmetrical we get only odd harmonics and there is no DC component, and that knowledge a student should have from signals, and this signal application now is linking to networks. Now the fundamental component of waveform, if you take that n is equal to 1 we get this, and with omega is equal to 5000. Now that component is like steady state sinusoidal component, and now at this component frequency of 5000 radians per second, if you substitute the reactances of inductor and capacitor we get it, and at that the phasor current can be calculated with that, and now the voltage across capacitor, Ohm's law, I into XC, which is around 191 volts. So see, this good question is linking multiple subjects where a student should have thorough knowledge on signals. So there are a lot of questions in this pattern where you should have fundamental knowledge from other subjects and application do link with other subjects. So that is why don't neglect, there are so many questions of this pattern, but I am just taking a sample question to show the importance of this subject. Then these are my referred books. Okay, I would suggest you to refer these books like Signals and Systems by Oppenheim and Wilsky, one of the old and great books, and other book is from Heiken, and we also have especially some areas like discrete time systems, Z transforms, etc. by Zimmer. These are very good books, and I suggest you to just do the solved examples rather than reading entire book which is unnecessary and irrelevant. Do the solved examples in these good books, and as I suggested, these are the things I would like to discuss with these basic subjects. Our team further talks about remaining subjects.
Dear friends, I am Shankar. I did my masters in power and control from IIT Kanpur. I am the faculty for Power Electronics subject in AC Engineering Academy. Till now you might get some idea on the overview of GATE exam pattern and the preparation strategy in this video from the previous slides. Now we will discuss about the syllabus analysis and what types of questions we will get it from the subjects power electronics and control systems. If you look into the power electronics syllabus, majorly it can be divided into 4 and 5 chapters. First one, basics of power semiconductor devices. In that we can get some theoretical questions on power diode, thyristor, GTO, MOSFET and IGBT, especially switching characteristics of these devices. And then line commutated thyristor based converters, you can take that as a second chapter. That means in simple terms, rectifiers. It has two major sections, one is a single phase rectifiers and the other is 3-phase rectifiers. And you can take the third chapter as DC to DC converters. In this chapter there are 3 basic converters named as buck converter, boost converter and buck boost converter. And the last chapter is DC to AC converters. It covers both single phase as well as 3-phase inverters. And in the overall syllabus point of view, the emphasis is on harmonic analysis. From then we can have some harmonic issues like what are the issues of line current harmonics, from then some performance indices, distortion factor, displacement power factor and input power factor. So this is the overall power electronics syllabus, and this is one of the important subject especially for GATE electrical engineering candidate. Why? Because after GATE, when you are going for higher studies like MTech and PhD, power electronics is one of the important specialization. Therefore, this power electronics, if you see the recent last 4 to 5 years papers, some new areas, of course it is not so advanced, but the related basic concepts from some new topics are also giving. So from the power electronics subject you can expect on an average 9 to 11 marks, minimum 9 and maximum 11 marks. Now let us see what type of questions we will get it. I think you might get some idea in the previous slides. The basic philosophy of the questions are 4 categories. Now in order to address the 4 categories of the questions, I took some sample questions from the previous years. We will see those questions one by one from the next slides. Now if you see, this is one of the question in the recent GATE 2017, this question is given. If you see this question, there are 4 devices are given: IGBT, MOSFET, diode and thyristor. Among these devices, different 4 options are given. Basically you need to identify which device comes under minority carrier device, which device comes under majority carrier device. If you read the basic theory of these 4 devices, just you need to identify from your recall, from your memory, you just need to recall what type of device and what category. So this question we can say a simple theoretical question, and it will not take much time also. This question I can classify under recall category. So one of the type of questions in the GATE exam, recall type, the simple theoretical question, the candidate is expected to recall the answer from their memory, and these are basically defined based on the small definitions and the principles of a particular subject. So if you see this answer for this, MOSFET is a majority carrier device, whereas the remaining devices comes under minority carry device. This is very simple. These type of questions just from the theoretical understanding, and you can save some time also, you can do very fast. Now next let us see the second question. Now if you see this question, one circuit diagram is given. First you have to identify what is that circuit. This basically comes from the DC to DC converters chapter, that is basically buck boost converter. So for this buck boost converter, some data is given, means some information is given to the candidate. If you apply the buck boost converter principles, then you need to find out, based on the given input voltage and output voltage, you need to find what is the range of duty ratio. By applying simple buck boost converter equations, you will get it. That means this question basically comes under comprehension model of the gate questions. So basically here the expectation from the candidate is they should know what is the fundamental principles of particular concept, and from then you need to apply small calculations. Finally you should arrive a conclusion. So for this, if you apply the basic formulas of buck boost converter, it will give you, for the input voltage of 32 volt to 72 volt, to maintain the constant voltage at the load side of 48 volt, we will get option A. Of course you need to keep these points in mind during the preparation. Gate questions are not so lengthy and not so short. The most of the questions based on the applying concepts to the given question. So I can say this question comes under comprehension category model, and this is also very recent question. Next, let us see the next question. And if you look into this question, this is also one recent question, and some data, a lot of data is given, and particularly let me read the question once. A single phase bidirectional voltage source converter is shown in the figure below. So a bidirectional voltage source converter circuit diagram is given. All devices are ideal. This particular converter is used to charge a battery at some power level. The source voltage is given, and some other information also given. Finally you need to calculate the phase angle between that VC1 and source current. Of course nowhere it is mentioned as what application it is. Basically this question comes under application of voltage source converters in the power systems. If you look into more detail, from the phasor diagram I can observe source current and source voltage are in phase. This is one of the power factor correction application in power systems by using power electronic circuits. So of course nowhere it is mentioned it is a facts application, but this is one of the facts application. So here expectation from the candidate is they need to apply the basic concepts of this circuit, and this is an application of power electronics in power systems. So I can take this question as application category of the third model of the gate question. And of course data looks more and circuit diagram is somewhat catching, but you can apply power balance concept. Input power is equal to output power, because it is mentioned that all devices are ideal. So by simply applying power balance condition, input power is equal to output power, and by applying small just let us see the solution in the next slide. You can say the power input power and output power both are same, and by equating that you will get that tan delta. The very small calculation, but the only thing is you don't scare about the question, and just go through the question, and if you apply the basic concept you will get the answer. And of course this question comes under numerical answer type question. Numerical answer type question will not have an options, as you might already get an awareness from the previous slides. So you have to enter the answer according to the units and within the range. So you need to perform this calculation by using virtual calculator provided in the exam itself. So for these numerical questions, my sincere suggestion is you should get some practice with online calculator, because most of our we will follow our physical calculator, but that is not allowed in the examination hall. And here this question comes under numerical answer type question. Of course, the difference between the previous question and this question, earlier question also numerical calculation, but that comes under MCQ category. So all 4 options are given and you need to come to one particular option, but this also numerical answer question, but this is a, you have to enter this number by using the online virtual calculator. Now let us see the 4th type of question, that is analysis and synthesis. So this question comes under MCQ, there are no numericals involved, but this question is not so straightforward. This is, it requires a strong understanding on the 3-phase full converter, and you should have thorough revision about the waveforms. So let me read the question here. A 3-phase fully controlled bridge converter is given, that is connected to the source of 3-phase AC source through a star delta transformer whose turns ratio is given as 1:k. It is operating at a firing angle of 30 degree, and the load current is given as a constant, that is maintained at 1 per unit. Of course, it is given that transformer is an ideal one. You need to identify from the given 4 options what is the waveform at the source side, that is a star connected winding side. So this you can get it by having an understanding on the source current waveform of 3-phase fully controlled rectifier. So 3-phase fully controlled rectifier source current waveform shape is quasi square waveform. So we will have 3 quasi square waveforms, each one has phase difference of 120 degree. From that, step by step if you proceed, and if you get the phase currents in the delta side, you will have a 6-step waveform of each magnitude of 1/3 and 1/3. So that from 0 to 60 degree, the phase current in the delta side will be 1/3, and 60 to 120 degree it will be 1/3 per 2/3 per unit, and in the remaining half cycle it will be 1/3 per unit. So after then, if you convert into the star side by using the transformation ratio, finally you will arrive at the solution of option B. Therefore, in this particular category of the questions, what I would like to emphasize, this question comes under analysis and synthesis category. You need to remember, in this particular category, lot of information will be given to you. You need to do some analysis. These are not straightforward questions. You need to do some analysis, and finally you should get some conclusion. Of course, these questions, if you have a clear conceptual understanding, then you can directly do it. Otherwise it will take more time. It will take a little time consuming questions. You have to identify. My sincere suggestion is, these type of questions are better to solve at the end of the paper, so that first if you start with easy questions, and finally if you do it these questions at the last, then you can save some time saving, and at the same time you will not get any tension also. And another important point in the synthesis category questions, candidate is expected that they need to identify irrelevant information for the question. At the same time, they need to have a critical assumptions. If any relevant information is not given, they need to have critical assumptions. So these 4 questions I would like to explain in such a way that recall and comprehension, and then application, analysis and synthesis type questions from the power electronics. So power electronics is a very conceptual subject. Every year some new areas or new questions are giving in GATE exam, and this is one of the important subject for higher studies also. So on an average we will get around 9 to 11 marks from this subject. Now I would like to show you what type of books you can prepare. So the basic, for the beginner, I will suggest Power Electronics by P.S. Bimra. If you are in the beginning stage, it is highly recommended to start with P.S. Bimra textbook. And P.S. Bimra devices part and the rectifiers part is good. But for the DC to DC converters and inverters questions, nowadays in the GATE exam, some advanced levels are giving. So I will suggest for that the second reference, Power Electronics Converters Applications and Design by Ned Mohan. Ned Mohan is a co-author, the popular is Ned Mohan book. And Muhammad Rashid, third reference is also good. I feel for any subject, one or two standard books are highly recommended. So it depends on your convenience, either you can follow 1 and 2 or 2 and 3, that is up to the candidate now understanding on the subject. Another strong recommendation is, of course, apart from the textbooks, it is highly recommended for each GATE aspirant to have your self prepared notes. That is highly recommended. I would suggest you can prepare the notes either by yourself by referring these books or by attending any experts classes. Normally you will get it such experts guidance and experts classes in our academy, AC Engineering Academy. You are welcome for that. So it is highly recommended that self preparing notes, either you can write it on yourself or from some experts guidance also you can prepare it. So your self prepared notes and any 2 or 3 references are highly recommended. Now let us move to next subject, control systems. In this control systems, the syllabus, if you see, the major divisions are, first part I can say mathematical modeling. In the mathematical modeling, ultimate goal is to get the transfer function, the relation between input and output. You can get the mathematical modeling and representation of systems by applying simple concepts, basic KVL and KCL and simple physical laws. These modeling part can be represented in the form of either block diagrams and signal flow graphs. Ultimately, the target from this particular area is to get the transfer function. Once you get the transfer function, the next is response analysis. Response analysis, again 2 models, 2 domains, time domain analysis and frequency domain analysis. And then the stability criteria, RH criteria, Nyquist stability and root loss also will be used to identify the stability analysis. Coming to the frequency domain analysis, Bode plots and Nyquist stability analysis also you can consider. And compensators and controllers, the very popular topics are lag, lead lag and different controllers, PI and PID. And finally, the state space model is another subject. So the weightage for control systems in GATE exam is roughly around 9 to 11 marks. So control systems is an important subject for EEE and EC students also, because in the MTech, in the higher studies, MTech and PhD, there is a particular specialization called control systems. For this particular subject, both electrical and electronics candidates are eligible. Now let us see in this particular subject what type of questions we will get it. Here also the first question what I showed here, the very simple concept. It just like in the previous subject power electronics, here also it is expected from the candidate to get the answer by recollecting some concept. So this question I can say comes under recall category. So let me read the question. Introduction of integral action in the forward path of a unity feedback control system results in. So this question is based on a very simple concept. If you introduce integral action in the forward path, you just need to recall the type of the system will be increased by 1. When the type is increased by 1, the steady state error will be decreased. So by just recalling this simple concept, you can identify the answer is B. This question I collected from GATE 1997. Next, let us see the next category of the question. So in this, one transfer function is given and Bode plot of that transfer function is given. Finally, what is the question here? what is the value of A upon Bk is. So it is not a straight question, some data is given. Of course, the data is not given directly as a theoretical data. The data is given in the graphical way, that is a Bode diagram. So from this Bode diagram, you need to apply some concept. What is that? When the slope is minus 6 dB per octave, octave means for every double in the frequency, that is equivalent of minus 20 dB per decade. Decade means 10 times of the increasing the frequency. So by applying this, you need to identify based on these slopes where pole is located, where 0 is located. By applying that one, you will get finally the value of A upon Bk. So by applying this simple step by step procedure, finally we will get an answer of A by Bk is 3 by 4. So from this question, what I would like to convey, this question can be taken under comprehension category. Some data is given to the candidate, from that apply small concepts of it, and then finally arrive at one conclusion. That conclusion may be either numerical or some theoretical conclusion as well. Next, let us see application category of questions. So if you look into this question, of course, one differential equation is given. That differential equation is the basic model of a DC motor. That means control system application in DC machine is given in this particular question. That differential equation is next step is arranged in the form of a state space equation. By arranging in that state space equation, the question is from the given 4 options, identify what is P matrix. Basically P matrix is state matrix in this. So just if you aware of state space modeling, how to express the state space equations, x dot is equal to Ax plus Bu, if you arrange the equation in that format, then you will get what is that P matrix. So if you write down these steps one by one, you will get a conclusion that we will see in the next slide. You have a conclusion of option A, the P matrix is given by this one. So this is basically rearrange the equation in terms of x dot is equal to Ax plus Bu, where A is a state matrix, but in this question that A is given in terms of another name P. So I can take this question under application of control systems category in the DC machines. Next, let us see somewhat of analysis oriented question. Look into this question. This question is given in GATE 2007. In this question, 2 diagrams are given. Block diagram approach. In the first block diagram, one physical system mathematical model is given in that form of block diagram. Finally, the block diagram in first figure is reduced into second figure, and from the second figure you need to identify what is the value of x, y and z from the given options. Of course, this is not a straight question and it is not a very short answer question also. It requires some mathematical analysis. So by using signal flow graph and Mason's gain formula, I can convert the first diagram into one signal flow graph. From then I can write down the loop equations. Finally we can get it in the conclusion. So that those steps are given in the consequent slides. Finally the transfer function is expressed in different steps. Finally you can get an arrival of answer. So here from this you can identify what is the value of x, what is the value of y and what is the value of z. So from these 4 varieties of questions from the control system subject, not only control systems or power electronics, you take any subject in the entire GATE paper, all the 4 categories of questions will be addressed. The expectation from the candidate is, it is not a straight and objective question paper. You have to apply your understanding on the particular given question. That is what the aptitude test of particular engineering discipline. Now another point is, all of these engineering questions directly not from pure engineering specialization. Sometimes some questions will be combined with mathematics also. For example, you will get some sort of questions from the Laplace transforms from the mathematics chapter in control systems area or signals and systems area, and Fourier series questions from the power electronics subject and signals and systems and from mathematics. Sometimes you will get a Newton-Raphson method solutions from the power flow equations of power systems and mathematics also. Like that, it is expected from the candidate to apply basic mathematical skills in the respective engineering disciplines. Now, coming to control systems, let us look into the reference textbooks. Here also my strong recommendation is self-prepared notes is highly recommended, and the basic books in the control systems you can prepare Nagrath and Gopal, and Modern Control Engineering by Ogata. This is also another important book, and Norman Nice. This is somewhat advanced book. Either you can refer first and second or first and third, but first is compulsory. And self-preparing notes is important. So this is what so by this time I think you might get some awareness on what is the overall gate pattern from the previous video, and what is the syllabus analysis, what are the books recommended for each subject. Now in the preparation, you just make a plan 6 to 8 months well in advance, and do not distract from other disturbances and focus on your final objective and prepare systematically. In this preparation, ACE Engineering Academy is there for you to help by giving guidance in the various forms. So for the GATE aspirants, ACE Engineering Academy will provide you classroom guidance. So classroom guidance also we will offer in different modes, and which is suitable for different aspirants. If you are in the college like third year or final year, and even second year also, you can start the GATE preparation. For second year and second year students, 2 years integrated programs are there in all our centers. And for final year students, if you are in the college, going students in Hyderabad, you can choose either morning batches or evening batches, or if you are far away from Hyderabad and if you are able to come here, you can choose weekend batches. Not only in Hyderabad, weekend batches in all our ACE centers, weekend batches are available. If you already completed BTech and looking for better rank in the GATE exam, and we are offering a long-term coaching, means regular daily batches. So in this we will have a very systematic classroom program. And if you are not in a position to attend a classroom guidance, we also offer you guidance through postal material, so that highly experienced faculty prepared well systematic notes, and we will send that material to you at your postal address. Apart from that, whatever the program you choose, the more important thing is you have to write down the exam. This is not directly pen and paper exam. You should write down the GATE exam at the computer. For that, online test series, for ACE online test series, it has very excellent feedback across India. Even if you take any social networks, every forum will tell you that ACE online test series particular to electrical engineering, it's a best one. Therefore, these are different offerings we will provide for GATE aspirants. So you first fix your target and prepare systematically, and of course from the previous slides you might know that GATE is not only for higher education, it is a platform to enter into the PSUs also. So with this, I hope you liked the watching video, and thanks for watching the video. I wish you good luck. Thank you.
Hello everybody.
I am Surendra Reddy, faculty for Electrical Machines, AC Engineering Academy. I did my bachelor's degree from Jawaharlal Nehru Technical University, Kakinada, and master's from IIT Bombay in the specialization of power systems. As part of this video, I am going to talk about electrical machines course. In this particular video, I would like to give you some related information regarding electrical machines. Now, we know that electrical machines is one of the important core subject which will be always important for GATE examination as well as engineering services examination. On an average, electrical machines will score around 10 to 12 marks out of 100 in GATE examination. And this particular course can be divided into 4 parts: transformers, induction machines, DC machines and synchronous machines. And you can observe in the slide, we have transformers subject and it can be divided into number of sub chapters. Single phase transformers we have, 3-phase transformers we have, operating principles, construction, equivalent circuit, that is one part of the transformer, and then testing of the transformer, efficiency and regulation calculations, and then 3-phase transformers. Out of this, I can say testing of the transformer, regulation and operation is going to be very important, and one need to have a strategical preparation in order to understand this subject. And the next part of this electrical machines will be induction machines. I can say induction machines is a continuation for transformers. The sequence must be, first you must learn and study transformers course, and the continuation will be induction machines, because induction machine is known as a rotating transformer. Out of these induction machines, you can say basically we will study more about 3-phase induction machines rather than single phase induction machines, because 90% of the applications are 3-phase induction machines. In that, the principle and operation, and then we have performance, speed, torque characteristics, testing of induction machines, various losses available, and most importantly speed control of induction motors, and also we will study some related information regarding single phase induction motors as well. After induction motors, we have DC machines is one of the rotating electrical machine that we have. This part is also very important and will score around 3 to 4 marks in GATE examination. I will show you very soon what is the marks weightage you can expect from each part of electrical machines. These DC machines will be divided into number of chapters. We have different types of DC machines, and we need to study about generating mode of DC machine as well as motoring mode of DC machine, and then we have to study about the characteristics of DC machines, which is a more important one. Using characteristics only we can define the applications of DC machines, and finally losses, testing and efficiency calculations. After that, another important rotating electrical machine that we have is synchronous machines, and we need to study various types of synchronous machines that we have, and what are the various regulation methods, and parallel operation of synchronous generators to infinite bus bar and various observations. And then we need to study about synchronous motors and their characteristics as well. And this particular electrical machines is also very important as for of interviews also. Not only for GATE examination, it is for engineering services examination and also for many public sector examinations, including state level examinations like generation corporation and transmission corporations. Now, I will show you the marks weightage for this particular electrical machines subject. You can see in the slide that from the past 3 years I have collected the data, and you can observe even the other years also. On an average, electrical machines subject will cover around 10 to 12 marks. If you see 2018 examination, overall we got 9 marks. In 2017, we have an average of 14 marks. in 2016 an average of 12 marks. And you know that electrical machines is a subject where theory part is going to be really important. First, the strategy for electrical machines subject will be, you need to learn theory part really well, and you can observe a question now I am giving you. It was a question based on the memory of a student. That means you read the question. When the supply voltage to an induction motor is reduced by 10%, the maximum torque of the motor will be decreases by how much percentage? It's a simple question, 1 mark question in one of the gate examination. A student can be able to answer this question if he remembers the maximum torque equation, because gate examination time management is very important. For this 1 mark question, you cannot derive the formula there itself in the examination, it is difficult. So one should remember the formula for this maximum torque, and you can see that formula in the slide. Maximum torque is equal to 3 by omega s into v square by 2x2, okay. From that formula you can understand that maximum torque is proportional to square of the voltage, that's it. When the voltage is reduced by 10%, then the maximum torque will reduce by almost 20%. So one will be able to answer these kind of questions if they were able to remember the concepts really well, especially mathematical formulas. Around 15 to 20% of the paper will be like this. Next thing is going to be questions based on the comprehension type. Comprehension type questions means it will be like analysis oriented. That means you need to be able to apply theoretical part on a numerical question. Now you can observe this question, which was going to be a question from both DC machines as well as induction machines. These kind of questions are very, very important, and around 30% of the paper will be covered by these kind of questions. In this particular question, if you wanted to answer here, you must have a clear understanding of DC machines concept as well as induction machines concept. But the one who understands that concepts really well, it will be a very easy question for them. Otherwise, it looks difficult. You can understand from that question, a DC machine is mechanically coupled to an induction machine, and it is clearly given that induction machine is connected to a 50 Hz supply source, and it is designed for 4 poles, and DC machine is driving the rotor at 1600 RPM. So from the given data, I can say the synchronous machine, the synchronous speed of the induction machine is equal to 1500 RPM, but the rotor is driving at 1600 RPM. Therefore, rotor speed is more than synchronous speed. That itself is indicating that the induction machine is operating as a generator, okay. So induction machine is operating as a generator means I can say that DC machine is acting like a prime mover for that induction machine. So therefore DC machine is a motor and the induction machine as a generator, okay. Alright, let me go to the other type of questions that we can face in gate examination. They are going to be application oriented. Now these kind of application oriented questions may interlink with any 2 subjects. I will show you a question now. This is a question based on transformer, but this question requires an understanding regarding superposition theorem. We know you will study about superposition theorem in electrical circuits. You can observe that a transformer has 3 windings there. Primary winding is connected to source, and the secondary and the tertiary windings are connected to loads. That means there are 2 loads available. So they are asking about what is the total current drawn from the primary side. In order to answer this question, you should be able to apply superposition theorem here, as we know that total response is equal to sum of the individual responses, isn't it? Very simple. So that's why as there are 2 loads available, I will apply 1 load at a time and I will find the input response and identify the total response by adding both of them. So a student will find difficulty without learning that superposition theorem to answer this question. Don't try to answer this question straight away with 2 loads. Apply 1 load at a time find the response, apply the second load at a time, find the response and find the total response by adding both of them. Next kind of questions that we can face in gate examination will be analysis and synthesis oriented. Answering these questions is required lot of theoretical concept. If you have complete understanding over the subject, then you can easily answer these questions. Understanding the subject completely is very, very important. That's the point I'm stressing again. You can observe a question. This is a question taken from DC machines subject, and it is a previous gate examination question. You can understand. A 4-pole lap connected separately excited DC motor is drawing a steady state current of 40 amperes while running at 600 RPM. Yes. What is the kind of the wave shape of current which is passing through armature conductors? So this is an objective type question. So negative marking will be there. So you need to be very careful while answering these kind of questions. A normal student who did not prepare really well may think that it is a DC machine. So in a DC machine, the current will be of DC shape. So they may pick option A as correct answer. That is a wrong one. Or option B, because both are DC there. But they are asking about current passing through each armature conductor. We know that in a DC machine, current passing through each armature conductor is nothing but current passing through each parallel path. As it is a lap connected machine, there will be 4 parallel paths available since 4 poles are existed. Total current 40 amperes means through each parallel path 10 amperes current will flow. So don't directly put option A as correct answer, it is 10 amperes given. That is wrong. Because we know that in DC machine, even though output after the commutation, even though the current is DC current, but in armatures, the current existed will be alternating type. This particular point is very, very important to answer this question. And there are 2 options available regarding alternating current. One will be a trapezoidal wave, that is also known as flat topped wave. Another one is a sinusoidal wave. As I said, alternating current, don't straight away select sinusoidal wave as a correct answer, but that is wrong. Even though it is alternating current, we know that in DC machines, pole shoes are arc shaped type. Due to the availability of that arc shaped pole shoes, the air gap between stator and rotor becomes uniform. That makes reluctance going to be constant. The moment when the reluctance is constant, the flux and MMF will be directly proportional. That's why we are going to get a flat topped waveform rather than a sinusoidal waveform. That is how you have to select option C as your answer. I am giving you some of the reference textbooks here. You can follow some of the standard textbooks available in the market. There are so many textbooks available, and I would like to give you some of the important textbooks which will give you course related to gate examination. We have Electrical Machinery by Charles Kingsley and Fitzgerald, one of the finest textbooks that we have. This is from Tata and McGraw-Hill publications. Electrical Machinery by P.S. Bimra. This is from Khanna publications. Electrical Machines by D.P. Kothari and I.J. Nagaraj. This is also from Tata and McGraw-Hill publications. My dear friends, this is Surendra Reddy and signing off. All the very best. Looking forward to you. Thank you.
Hello friends, myself Giri. I am faculty for Power System subject in AC Engineering Academy. I did my master degree from Indian Institute of Technology Kanpur and bachelor degree from JNTU Hyderabad. Till now our faculty colleagues explained what is gate exam, what is the importance of gate exam, what is the subject wise weightage marks for electrical engineering paper, and what are the previous year cutoff marks and top marks. Now you got some idea about gate exam for electrical paper, and also you have an idea about how to prepare, because already our faculty colleagues explained what are the strategies you need to follow. Now I want to add a little more for that. When you are preparing any subject, first thing, please concentrate more on
basics and fundamentals, because basics and fundamentals are foundation for any subject. Then practice some important derivations. Then remember some important formulas, and don't forget empirical formulas, because empirical formulas are very important, because they talks a lot about the concept. And one more thing, while practicing any formula, please see what are the parameters in that formula and what are the values you need to substitute for each and every parameters. I will take a simple example. In power system, you know, the power flowing through a transmission line is V1 V2 by X sine delta. Now you should understand what is V1, what is V2, what is X, what is delta, and moreover whether V1 and V2 is phase quantities or line quantities. So these things you need to be very, very careful. For example, if the question is given, calculate power flowing through a 3-phase transmission line, you will give all the parameters: sending end voltage, receiving end voltage, load angle, reactance of the line. Then when it comes to answering of that question, he will not mention really whether it is a 3-phase power or single phase power, but by default it is a 3-phase power. And if you want to get 3-phase power, V1 and V2 must be substituted as line quantities. If you substitute V1 and V2 as phase quantities, definitely you will get a wrong answer, and that answer will be among the 4 options if it is a MCQ multiple choice question. So that's why please be careful about these things. Formulas are very important and substitutions are very important. And then practice more number of problems, because if you see previous gate paper, almost 70 to 75% of the questions are numerical questions. So at the end of the day, it is really matter that how many new questions you are practiced, how many new questions you are expertised, because if you see almost 90 to 95% of the paper is new, means the previous year questions generally not repeated. So that's why it's really matter that how many new questions you are practiced. So practice more number of problems. So you will get, I mean, you can see previous year gate papers and previous year IES papers and previous year IAS papers, and also take any standard good standard textbook and practice example problems, and if you have time, even you practice exercise problems also. If you do this for every subject, definitely you will get better results in gate exam. Now we will go through syllabus analysis for power system subject. You know that power system is a very important core subject for electrical engineering paper, and also you are aware of this. Power system is a very lengthy subject and it's not a tough subject. And if you see the weightage for power system subject, approximately 11 marks, minimum 10 marks, maximum 13 marks. Now I divided the power system syllabus into 5 major parts. If you see this slide, first one, power generation concepts. From power generation concepts, truly speaking, you are not getting much questions for gate exam. Hardly you are getting 1 or none, 1 mark or 0 mark. But this topic is having good weightage for engineering service exam. So that's why the people who are preparing for engineering service exam give a good time for power generation concepts. Now in power generation concepts, we will go through hydropower, thermal power, nuclear power, and some non-conventional energy sources like wind, solar, etc. And also you should know which are base load plants, which are peak load plants. Sometimes simple question will be given, which of the following plants is best suitable for base load, and which of the following plants best suitable for peak load. So get a proper idea about which are base load plants, which are peak load plants. Now the second topic, transmission and distribution. I can say it's a very lengthy topic. If you see the subtopics in this, basics, where you need to concentrate on what is complex power, what is active power, what is reactive power, what is apparent power. You may already studied this in network theory subject, but still see what are the formulas for apparent power, active power, reactive power, complex power, and then try to understand conventions of the power system. There are basically two types of conventions in power systems. One is generator convention and other one is the load conventions. Try to see what is the difference between generator convention and load convention. This is very important because many electrical engineering students not having good idea about generator convention and load convention. So please get clarity on this. And then you need to understand what is lagging wires, what is leading wires, and also you need to see what are the different types of conductors which are used in transmission system and distribution system. And also you need to see the application of different types of conductors. For example, AAAC conductors, ACSR conductors, where you have to use this. And then second topic, if you see, line parameter calculation. You know, there are basically 4 parameters. One is resistance, inductance, capacitance and conductance. But inductance and capacitance calculations are very important. In this subtopic, we come across n number of formulas, but don't fear by seeing the formulas. There is a simple logic for remembering these formulas. I'll tell you a simple way. Inductance is 2 into 10 power minus 7 ln GMD by GMR, and capacitance is 2 phi epsilon naught by ln GMD by GMR. That means if you calculate GMD and GMR, and it's not a big deal to calculate inductance and capacitance. So that's why for every configuration, try to understand what is GMD, what is GMR, and practice more number of problems on GMD and GMR, so that if any question is given from this topic, you are in a position to give the answer. And one more thing, sometimes the direct question will be given on GMD and GMR calculations. So even you can go through previous year gate papers, you can able to notice this. And then next, performance of transmission lines. Here we need to see how transmission line is performing, whether the transmission line performance is up to the mark or not. But how to know this? Simple, by calculating regulation and efficiency. So by calculating regulation and efficiency, we will see, or we will say whether the transmission line is performing properly or not. So for calculating regulation and efficiency, we are classifying the transmission line, short line, medium lines and long lines, so that we can go for some approximations. And also we take the help of ABCD parameters for calculation of regulation and efficiency. And also you need to concentrate here static power flow equations in terms of ABCD parameters. That is also one important area apart from regulation and efficiency. The next topic, traveling waves and transient analysis. So here first we need to see what is propagation constant, what is attenuation constant, what is phase constant, what is lossy line, what is lossless line, what is attenuated line, what is attenuation free line, what is distorted line, what is distortion free line, what is infinite line, what is flat line, what is tuned line. Now these definitions are very, very important. Sometimes simple questions will be asked from these definitions. So be careful about this. And also you need to see surge impedance. What is the typical surge impedance for underground cables and transmission lines? And what is surge impedance loading? What is its importance? And then what is reflected coefficient and refracted coefficient for voltages and currents? And also what is voltage reflection, current reflections? There are simple formulas. You need to practice these formulas and also some problems. Then voltage control. In voltage control, the name itself is saying we are controlling the voltage. That means what are the methods to control the voltage? Because when it comes to the load centers, the voltage may dip. There are a number of reasons for this. You need to see what are the reasons for voltage fluctuations. Then next we need to see what are the methods of voltage control. There are so many methods of voltage control. Try to understand each and every method. And then power factor corrections. You know, in power system, especially load side, we try to improve the power factor to unity. That means ideal power factor is unity, but economical power factor is slightly less than unity. So our efforts is bring the power factor close to unity. But why power factor is less than 1 and why power factor is poor, you need to understand. Simple answer for this: 80% of the loads are induction motors in power system. Induction motors are consuming huge amount of reactive power. That is one reason I can say. So by reactive power compensation we can improve the power factor. He'll ask a simple question: if the power factor is improved from 0.6 to 0.8, then calculate what is the rating of capacitor at the receiving end side. And this kind of questions you can practice. And then insulators. So insulators are generally used in overhead transmission and distribution system. So you need to see here types of insulators and insulation materials. And very important here is voltage distribution calculation. So you need to calculate voltage across each and every disc in a suspension string. You know that the voltage distribution across the suspension string, I mean to say voltage across each and every disc is not same. That's why string efficiency we can calculate, that is generally less than 100%. If it is equal voltage distribution, you will get string efficiency 100%. So here we need to calculate what is the voltage distribution and also what is string efficiency and what are the methods to improve the string efficiency. And then underground cables. Here we need to concentrate on what are the different types of cables, what are the insulating materials, then what are the different components in the cable, and how to classify the cables based on operating voltage, based on number of cores. And then very important here is how the electrostatic stress distributed in the insulation, because by seeing electrostatic stress we can see whether the cable insulation can withstand for that or not, or indirectly we can design the cable to withstand for that electrostatic stress. So electrostatic stress calculations are very important. Truly speaking, electrostatic stress is not uniformly distributed in the insulation. So we need to see what are the methods to equalize the electrostatic stress. And then corona and distribution system. These are the very simple topics. Okay, so that's about the T&D topic. The next topic is power system analysis. So here first we need to see per unit system, because when you want to solve any power system engineering problem, there are two methods. One is you can go with absolute analysis, other one you can go with per unit analysis. But you know that if you do the calculations with absolute systems, it is very complex. It's just because of transformers, because impedance referred to primary and secondary of the transformer in absolute system is not same. But when it comes to per unit system, the impedance referred to primary and secondary is same. So that's why all the analysis means load flow analysis, stability analysis, and fault analysis is carried out in per unit system, not in absolute system. So that's why per unit system is very important for power system analysis. In fact, it is a very important topic in power system. So per unit system, you need to see what is the per unit value, what is the actual value, what is the base value, and the calculations with respect to that. Then symmetrical components and sequence network. This topic is very important for fault calculations. And then fault analysis. Here we need to see fault current calculations for different types of faults. For example, LG fault, LL fault, LLG fault, three-phase faults. Because this fault current information is very important for designing of protection system. Means for calculation of settings for protective relays and selection of circuit breakers, the fault current information is very important. That is why we are doing fault analysis. Then stability analysis. Why we are doing stability analysis means, sir, there are n number of disturbances may happen in power system. Continuously power system subjected to so many disturbances. But if there is a disturbance in the power system, whether the system is stable or not, whether the system is able to recover its synchronism back or not. So that's what we are going to study here. When it comes to the calculations, here we need to see steady state stability and steady state stability limits and transient stability, critical clearing time calculations, critical clearing angle calculations. That is what we need to focus in stability analysis. And remember one thing, there are some formulas where you can get direct questions, especially in stability analysis. Kinetic energy, momentum, inertia constant, and the relations between them. So these things also very important. And also you need to see what is coherent operation, what is non-coherent operation, what is bulging effect. So these things also very important in stability analysis. And at the end you need to see the equal area criteria by which you can calculate critical clearing angles and critical clearing time. And then load flow analysis. In load flow analysis, very important is Y bus calculations. And then classification of buses. For example, if you want to classify the buses, slack bus, PQ bus, PV bus, and what are the conditions to be satisfied to say it is a slack bus, it is a PQ bus, it is a PV bus, and these things are very important. And then finally you can see some load flow calculation methods, Gauss-Seidel method and Newton-Raphson methods. In fact, decoupled and fast decoupled methods is not mentioned in the syllabus, but at least you should have you should understand about the procedure for fast decoupled method and decoupled method. And when it comes to the Newton-Raphson method, the calculation of Jacobian size is very important. Sometimes direct questions will be asked from calculate the Jacobian size. And sometimes direct questions will be asked from Y bus calculation. So that's why Y bus Jacobian is very important. And then the next topic is power system protection. So here protective relays and then circuit breakers we are going to study. So if you see protective relays, concentrate more on principles of the relays, means overcurrent principle, directional principle, distance principle, and differential principle. Don't concentrate much on application part. Because if you see the previous gate papers, there is no much weightage is given to power system protection. Hardly you are getting one question. And if you see some years, even you are not getting a single question from protection area. So that's why, so prepare accordingly, I can say. I'm not saying that leave this protection part, because protection is very important for PSU interviews and engineering service exam interviews. So that's why take the protection accordingly. So you should have the fundamentals of protection, that is very important, I can say. But it is a less, it's not important for what? A gate exam. And then load frequency control, where you can expect one question. Here we can see how the frequency will be controlled with respect to the disturbances in the power system. So these are the power system topics. Now we'll see what are the weightage for each and every topic. The first topic, power generation concepts, where you can expect 1 mark question, sometimes no question from this area. Then T&D, where you can expect 2 to 4 marks. Power system analysis, it's a very important area in power system subject, where you can expect 4 to 6 marks. Then protection, from this area you can expect 2 to 3 marks, sometimes no questions from protection area. And load frequency control, you may get 1 question. That's a weightage from subtopic wise. Now we'll see references. So best book for power system subject is Power System Analysis and Design by Duncan Glover, and second one, Power System Analysis by Stevenson, and a third one, Power System Engineering by Nagaraj Kothari. If you see these 3 textbooks, the protection is not properly covered. That's why I'm suggesting one more book, which is especially for protection area, which is Switchgear and Protection by Badriram and Vishwakarma. Now, even I given references, but I can say the best book for preparing power system subject is Expert Classes, and also the notes what you prepared. So go through the syllabus and also prepare the notes accordingly for that, and definitely you will get a good marks from power system subject. All the best.
These are my general suggestions. Now the student who is going to attempt this gate, now sir, first of all study 100%. Don't ever take such wrong suggestions that leaves his subject. No, these are competitive exams, sir. Let me be very, very clear. It is not about passing or failing with 70%. If you get into the top, get into top 100, top 10 and even first rank, then you have wide range of opportunities either to join PSUs or MTech or PhD, whatever it is. But read everything. Don't neglect any subject. So first read 100% of the syllabus, but concentrate on scoring and easy subjects first. That will save a lot of time and remove the pressure. Then you should know what to study and what not to study. So irrelevant data, some question is linking out of the box, leave them. Let us be relevant to our subjects and link to topics, but not unnecessary areas. Then plan each subject topic wise with timetable. While preparing technical subjects, make a macro notes. Now macro notes is another idea where I would like to put a book while reading any textbook, write important points and important formulas, important circuit diagrams to remember, waveforms, etc. So make a mini notes, micro notes, so that you can easily revise and remember for fast revision, which will again save a lot of time rather than reading second time textbook. Then study all solved numerical examples from standard prescribed textbooks, because highly numerical, sir. Just reading theory has no value in GATE. Then try to solve available numerical problems from all the previous GATE questions of each topic and each subject. Then revise the subject at regular intervals for memory, speed and accuracy. So how to remember all this, so many subjects, so much of content, so many formulas. The best way is to revision here and there, revise. So that is the best way to recollect and remember for a long time. at least up to until you write the exam in January, February, and lot of speed and accuracy will come. And start reading topic wise of a particular subject. Like I would give an example, like you are starting theorems. Example, like in networks or electrical circuits, you take theorem chapter. First read all the theorems from the prescribed notes, then go to all the gate bits of EEE EC instrumentation. So that topic wise complete it perfectly, like the complete bandwidth of theorems in DC circuits as well as AC circuits from the entire available data of notes and previous gate questions of all the branches. If you can complete all the bandwidth, by that time you would have covered almost every angle and every concept of theorems. So like that, each topic thoroughly read, then focus more on important topics based on the previous papers. Then as I told, that micro notes should help you for quick revision. Then have a desire and sustain this desire and energy until the exam. So most of the students deviate after they get campus placements, after they get bored and they know the standard. So don't deviate, that is another important thing. Then practice some full length papers to get the thorough knowledge and estimation in time. Then attempt all online test series. As I suggest, from AC Engineering Academy, we do conduct a lot of online test series. So please attempt and then analyze and improve from every exam. Then while solving problems, get trained on virtual calculator. Now you know calculators are not allowed in GATE. So please practice on virtual calculator for the final exam. Then maintain good health and proper sleep. And as I suggest, our classroom coaching and study material from AC Engineering Academy is specifically designed for these exams, which will definitely save a lot of time. And then I want to also brief out about my institution where I am working. That is our objectives of ACE, which are simplifying the things and making students achieve their dreams in a very easy way. Now we have a lot of areas we give coaching and training for students, like engineering services exam. Then we also give for GATE, we are specialist in that. Then PG set, of course you know the standard what we give here is good enough to attempt so many other exams like PG set, UGC net for PhD, and then campus placements, of course for core companies in your college, placement in public sector undertaking. Some exams like HL online exam, ISRO, they do this here and there in the middle of the year. The same GATE knowledge and the material what we give is good enough to crack them. Then strengthening the subject knowledge of your BTech, and then specific exams like HAL, DRDL, etc. Now, yes, we do provide classroom coaching, study material, test series, career guidance, and motivation for success. And we also offer online test series. I would suggest that you do register high quality question papers, which will start almost 6 months before exam, and you can always take up whenever you prepare any particular subject. You can take these exams and attempt them and take a feedback to correct yourself. So that is what I would like to just conclude with these statements, that manage time effectively. Though 1 year is there, you have to be very careful and plan the subjects accordingly. Control your emotions, don't deviate. Improve accuracy by a lot of revision, and read the best study material. And motivation, we are always there here. And to be successful, please do follow what we are saying, and my team is to make you get this achievement, and we do our best to get into this, and we are specialists in giving this coaching. So all the best. Thank you.